Right.
You're one step away now.
So you just
divide
Careful.
You're going to divide it.
Divided by
N minus
minus
1.
no.
N
I don't have an n
minus
plus 1.
N minus 1.
So you got to divide it by what it's multiplied by. How do you get rid? How do you get the d by itself? Get rid of the n minus 1.
Right.
Now,
to the other side too.
exactly. So d equals this. The thing I'm hearing though is you guys think that you change the sign. No, no, no. You do the opposite operation. Why did I put a minus a here? I didn't change the sign. I did the opposite. This is this plus this, so I'm subtracting it. So if I have something multiplied by something, I divide by it. No need to change the sign. That's not the opposite operation. The opposite operation is divide.
So it turns it into an equivalent of 1, so it's just gone.
Yeah, this divided by itself is 1.
So you cancel it out.
Cancel it out. Exactly. All right, cool. How we doing?
Because then what you want to do, you want to isolate the d by itself. So what you're trying to do, you're trying to get the a to the other side.
The very first thing, isolate the term that has it in it by itself. So that I can almost always divide last. I don't make fractions too early. If you divide by n minus 1 here, you got to divide everything by n minus 1. You got a fraction and a fraction. And all fractions and letters. I don't have to do that, so I'm not going to do it.
So the answer is that
Answer
one
is that.
term minus d.
So d equals
A,
this
big
much.
A over little a over n.
A minus a over n minus 1.
So you think of d as a variable and n minus 1 as a number.
Yes.
As you do it,
Cool.
the equation. Okay.
I love it. Because that's all it is. It's a number I don't know yet. Now this one hopefully wouldn't be too evil. I mean, the only operation going on is
Is getting
multiplication. So if I want to get rid of anything, I just divide it. What do I want to get rid of?
N R.
So I divide by it. So I get PV. Those go away. T equals PV over NR.
So on the test, if it's like capital R, like it is there,
A little r would be
lowercase
different.
r,
Yeah.
we get points.
Because like very often in physics, has anybody ever done any electrical work or you used to coaxial cables and all that? You have stuff on the outside, you have an inner.
Yeah.
See, you normally have a big R for the big radius and a little r for the little radius. Upper and lowercase letters therefore must mean different things to keep it straight.
If we accidentally like put a lowercase r instead on the test,
Oh, I see. Only if there was another, if you made that a lowercase,
Okay.
that would be a problem because there's another lowercase. But if you made that r a little r, then you're just using a different dummy variable, that's fine.
Okay.
Because that's another name for these, just dummy variables. Why did I use P there? Because it stands for pressure.
Oh, geez, if anybody
Couldn't I use M instead if I really wanted to? Sure, why not? Right? Doesn't matter, it just stands for the number I don't know yet. Okay. Now here, who got this one? Who knows the first step on this one?
Subtract PRT from the left.
Careful. No.
No.
divide.
P outside.
I appreciate that though. You do get P by itself in that way, sort of, but they're on both sides, and so it's not really by itself.
So you get rid of R.
So here's what I meant, and this is when I thought people were going to stamp out. There isn't two P's there. There's one P that's been distributed.
Van één pi gaat.
So undistributed.
1 plus RT.
I love it. Right? What must have been here? P times 1 is P. P times RT is PRT. So I undistributed a P out. Now it's easy. Now it's cool.
Yeah.
I want P by itself. I don't want this crap. How do I get rid of this crap?
Minus RT.
No,
Divide.
divide.
Divide by
1 plus RT.
1 plus RT.
The beginning, you say to the PRT, just change it into a 1.
So if I take a P out, so for example, now watch, stay with me. Little side
Well, why
note.
would I put it in parentheses? It's an addition, it's a plus or
Because-
something.
Side note. If I had, what's that if I multiply it through?
Multiply through M plus AB.
AB,
M.
M,
So
right?
you got two M's. That's the
Now
same.
math goes both ways. Think of it what you will. So if I can go this, I can certainly take it back out. That's all I'm doing. I don't want it to look like that because then I got what looks like two P's, and that sucks. I'm trying to solve for P, and there's two of them. Oh shit! So I just say, whoever did this is a dork. Let me just undo it. Let me take the P back out. There you go. Now I've got one P, right? What must have been in here? A 1, because P times 1 is P, and an RT, because P times RT is PRT. Some of you guys might know that that's called GCF, the good old greatest common factor. Figure that guy out. So here I divide by the mess I don't want. Divide by the 1 plus RT. And there you go. Bam. So whenever you have more than one variable that you're trying to solve for, get them all on one side, factor it out. Take it out. Those are actually end up being the easier problems if you let it. Very short. Take it out, divide, and you're done. Sweet. Alright, so now let's see. Alright, good. We got enough time. I want to do some word problem work with you guys. And I've got a handout that I'll bring the answer key for next time. But let me first kind of go over the steps of a word problem. Then we're going to work on this handout. We're probably not going to get it done today, and you can do as much or as little of it as you want, because I'll have the answer key next time anyway. So it's up to you how much you want to do. And I know going in how people feel about word problems. Right? I've been teaching math since 1998. Holy shit! I already say that, like, really? But so I think I've heard it a few times, but. Here is, you don't have to do it this way, but I highly recommend that you do some version of what I do because it keeps things straight. So let's just take one right out of the book, just as an example. Here we go. Number 2 on page 125. I'll show you all the steps. So that should sound very familiar. It's all these weird people that are building gardens that don't know, they don't know what to make of it. Like, well, dude, man, that's your number 1 problem. But we'll help them out, right? So they're trying to make a rectangular, enclosure here. The length of the rectangle is 5 times the width. The perimeter is 48 inches. So they got like 48 inches of little wood stuff here, right? They're going to make a diorama for class. They have 48 inches of wood to make this little rectangular enclosement, right? You can have the world's smallest horse in it. So the first thing you do when you read through is not mathematical at all. That's a pretty small one. But whenever you have this huge word problem, you first look through it, you're just looking for the players. What's involved in this problem? How many things are involved in this problem? And what are their names? You don't care about the numbers. You don't care about the 3 more than twice. You don't care about that.
The width and the length.
Width and the length. Right? So I've got a rectangle. So you can, step 0 I'm going to call it is draw the picture. I call it step 0 because sometimes you can't do it. The shirt is on sale. You don't want to draw a little shirt. It's not going to help you. Right? Draw the picture. Got a rectangle. What are my players? You guys see what I mean by players? Like, just the things involved in getting this thing together. The length and the width.
And the total, right?
Now the interesting thing, the perimeter is how the length and the width, what they do together. It's not its own thing, it's what they do together, right? So the length and the width are the 2 key parts of this. Because if I make it longer, that's less wood for how wide it could be. So they play off each other. Those are the 2 players. Which one of those is just X or A or W or whatever?
Whichever one they don't
The
do.
width is X.
They don't give me either one.
The width is X.
Why is the width X?
Because the length is
Length.
5 times.
5x.
No, so I want to stop right there. Some of you guys know this already, and that's great. If you're good with word problems, just say hallelujah and just sit there. The rest of us, it is so key to know which one is just X, because that's what builds everybody else up. The length is 5 times the width. So of course, who do I have to know first? The width.
Yeah.
So that's why it's X. So if I say the width is X and the length is 5 times that, the length is 5X. I love it. Now, if I label this thing, here's my width, X, my length, 5X. What's this? X. It's got to be the same, right?
Yeah.
Make a little rectangle, 5X. I know mine is not geometrically sound, but it's okay. Here's the mistake everybody makes. How does the 40 inches come in now? So what are the players? That's step 1.
48.
Step 2 is, what's just X? Step 3 is, Build everybody else. Does that, do you make sense when I say build? Build off the top of X? If they would have said it's 5 meters more than X, then I would have done X plus 5.
What is?
So, draw a picture. What are the players? The English. You don't have to worry about the math, just the English. Then give them names, right? What's just X? Build everybody else. Once I give them names, I can work with them. So here's the English names. I need the math names. And now step 4, amazingly enough, is make the equation. So of course, the mistake I see all the time is this. I actually either see this, which I think everybody can agree that's not right.
No.
And normally somebody writes that who skipped everything else. They see the 5 times as long, and they say, okay, that's 5x, 48 inches, 5x equals 48, I'm done. What? So what's the main thing that they forgot there?
Got X and the both sides of
I love it. So the first little step they forgot is, and then I see this. That's still wrong. What's the question before you two?
I was going to say, can't you just go 10x plus 2x?
I love it. Exactly.
48?
Of course. But you can understand why people would do that.
That's
There's
right.
people those are the people that did this, but they didn't draw the picture for themselves. And they go, okay, well, x and 5x has got to be the 48 they gave me. Well, no, then you've only enclosed half of it, and the little horse goes, you know, you lost the smallest horse. I'm sure that cost a lot of money. You could get a lot of money for that. All right. So, of course, the mistake they made there, like you said, you can go 10x plus 2x. That equals 48. Because you got to go all the way around that bad boy. Some of you guys might realize here, x plus 5x would have to equal half of that. You can actually do that if you see that. But this will still work too. What do you get there?
12.
Now for step 5, solve. So 12x equals 48, so x is 4. Then you can come back up here. Here. X is 4 what?
Wait.
Inches. X is 4 inches. So the width is 4 inches, and the length would have to be 20 inches.
Really small horse.
Very small. Okay, cool. All right, let's do a couple more. I'll give you the handout, let you guys start kind of working on a few of them, and then we'll head out. That's kind of like, obviously it's a geometric word problem. Let's do one that's a little different. Let's do, here we go. Everybody's other favorite here. This is percentage problems. So I'll give you an example. I'll make up an example here. Right, this is the one that says a CD is on sale for 18% off, right? The sale price is what, Jeff? I don't know. Let me make it actually work. That'd be neat if I could make it. $16.40. What was the original price? And the mistake everybody makes is that they're way too optimistic about not needing algebra. What do you think people do? In fact, this might be what you're thinking about doing. They take 18% of 1640 and then add it back. What is wrong with that?
You're missing the rest of the number because that's it. You didn't get the whole 100%. You didn't take away.
Because what did you take 18% of to get here?
The
bigger number, the original price, right?
Yeah.
So if you take 18% of where you are now and add it back, you're never going to get back up to where you were, right?
No.
So like an old thing I used to say, what if I got my paycheck and they cut my pay by 10%? Let's pretend I make $10 an hour. And they cut my pay by 10%. Now I'm making $9 an hour. I'm pissed. I go in there, you guys really say, okay, we'll increase your pay by 10%. Don't worry. I start to walk out, but I'm a math geek, so of course I'm still pissed. Because now 10% of 9 is 90 cents. Now I'm only making $9.90. And some of you guys might realize 10 cents an hour adds up. So I'm still pissed, of course, because you'll never, 10% is not equal to 10%. It depends on what it's of. So you can basically never take the end result and try to get back to where you were directly. You've got to use algebra. That's what algebra is invented.